Okay, in this one we are told that an inventor was invited to the show Dragon's Den on CBC and claims that she or he developed an innovative design for a heat engine capable of receiving 300 kilowatts of heat from a reservoir of 1000 Kelvin and rejecting 100 kilowatts to a reservoir of 400 Kelvin. So this inventor asked for $1 million, Canadian dollars, investment for 20% of the company. As an engineer, you are asked to give your opinion on the invention to one of the dragons. And the question, what will be your advice and why? So this is problem 6.11, okay? Let's sketch this. It's always good to sketch our problems. So what do we have? We know that we have two reservoirs, okay? And between the two reservoirs, this inventor is claiming that he or she can put a heat engine with certain characteristics. Okay? So what do we know? We know that T hot is equal 1000 Kelvin. And we know that T cold or T low is equal to 400 Kelvin, right? This is exactly what we have. And we are told that this inventor is claiming that we have a heat here extracted of 300 kilowatts, and here the heat rejected is 100 kilowatts. And we are capable of producing a certain power. So this is for our heat engine. So fair enough. Okay, so the way we have to analyze this, and typically when we have to evaluate a claim, it's an indication that we have to calculate at the end of the day Carnot efficiency. Okay, so this one is our QH, and this one is the one that we are rejecting, no choice, because of the second law of thermodynamics, Kelvin-Planck statement. So what we have to do, the first thing, let's calculate the thermal efficiency of this heat engine. Okay, so let us compute the thermal efficiency of the heat engine following the claims of the inventor. Of the heat engine. So a classic, so we know that the thermal efficiency is equal to what? Is equal to the power over our heat N, which will be Q dot H here. So you will see that we don't have the power, a value for the power, fair enough, because we have a very strong tool. It's our first law of thermodynamics, okay? So if we take this as a control volume, the energy in has to be equal to the energy out, okay, if it's a steady state. So therefore, we'll be writing the input here will be Q dot H is equal to the two outputs, W dot plus Q dot L. So this is what is exiting, okay? Put the dots here. So therefore, from here, what we can calculate that the power is simply Q dot H minus Q dot L that I can replace here, okay? So therefore, this will be Q dot H minus Q dot L over Q dot H. So let's replace with the values that this inventor gave us. So this will be equal to 300 kilowatts minus 100 kilowatts over Q dot H, 300 kilowatts. This will be giving us a value of 0.667 or 66.7%. So this is the thermal efficiency of the heat engine as designed or following the claims of the inventor. Okay, for the moment, nothing crazy. Okay, the numbers are fine. We are not violating the cycle of thermodynamics in the sense that this one is not equal to 100%, so everything is okay. But we have a very strong tool now, which is Carnot efficiency. So we'll be calculating the maximal efficiency for any heat engine running between TL and TH. And then we'll compare with the claim of this inventor. So now let us compute the efficiency of a Carnot cycle of a Carnot heat engine, to be more precise, engine running between the two temperatures TL and TH. And this will give us a reference. Now, if the value we'll get is higher than this one, so if Carnot efficiency is higher than this one, it's good, okay? So you might basically, your recommendation that the Dragon can or cannot invent, but at least this inventor is not violating any laws of physics. If Carnot efficiency that we will get is lower than this one, it's simply impossible, okay? And your recommendation is that just run away and don't put any cent. So Carnot efficiency for this specific case is equal to what? Is equal 1 minus TL over TH. And here we have our TL is 400 Kelvin. No need to convert to Kelvin, it's already given, over 1000. And this will give us 0.6 or 60%. And here we have a big problem because the claim of the inventor leads to a thermal efficiency which is higher than Carnot efficiency, okay? So the efficiency claimed by this inventor is higher than Carnot efficiency. And since you can't beat Carnot, so this will end up impossible. And I like actually to put so far, because in science, you never know.